Dance learning requires time and practice. How can wearable devices support this process and make it better and more effective? I am Steeven and I will be presenting on behalf of my co-authors our paper entitled Assisting Motor Skill Transfer for Dance Students Using Wearable Feedback. Dance plays an important role in everyday life. However, mastering a motor skill is not trivial. In an ideal case, a student and a teacher will have personalized sessions where the teacher provides one-to-one feedback to the student. However, this is not always possible, since most of the dance sessions take place in medium to large groups, making hard to the teacher to follow the progress of every student. Literature in wearable devices for motor learning covers in reasonable detail technical aspects as feedback quality, interaction type, usability of the system, performance of the device itself. Yet it somehow overlooks the neural basis of motor learning, which is the phenomena happening in the brain of the user of the device. In this paper, we invite designers and researchers to include the insights from neurobiology into their research agendas and their design process. And here is where our contribution takes place. We bring the knowledge from a motor learning neural model and ground it into design recommendations with the help of dance teachers and students. We conduct interviews with 11 participants. 5 of them were dance teachers, with experience ranging from ballroom dance to performance dance. We use Doyon model as guide. This model considers 5 stages that describe the path from absolute beginner to skill behavior. These 5 stages are slow learning, fast learning, consolidation, automatization, and time delay. We include the first 4 stages of this model in our interview protocol. We created 4 vignettes based on these stages of the model in order to make it easier for our participants to imagine and embody the situation where they will be learning a given movement. The scenarios were adapted to match either the student or the teacher perspective. After we present every scenario, we discuss with them what are the strategies they use to teach or learn in that specific context. But let's explore more in detail what these stages mean. The fast learning phase occurs in the first session, when the student faces for the first time the motor task. This stage is attention intensive and induces high cognitive workload. Proper corrective feedback is essential in this stage in comparison with the following ones. In the subsequent sessions, the second phase of this model starts. The refinement of the movements happens across sessions and not in an individual session. This could make the students feel that their progress is slowing down. The consolidation phase is the intermediate process between sessions. We can place this stage as the bridge between the fast learning stage and the slow learning one. This consolidation is the one transforming the explicit instructions obtained in the practice into implicit memories that can be retrieved later in the next stage. The last stage included in our protocol is the automatization stage. Here, the execution of the motor task does not require a high cognitive effort anymore, and the execution of the motor movement can be done automatically. We applied an iterative analysis process combining open coding and thematic analysis. First, 2 of the authors coded 35% of the material. Afterwards, when we agreed in a coding tree, 1 of the authors coded the remaining interviews. Then we used thematic analysis to derive a more abstract understanding of the data. We identified 5 themes in the interview data. First, teaching and learning style. That includes the strategies and approaches that participants use when teaching or learning a new movement. Second, we have the difficulties. These are the common mistakes and the classic problems that students have when learning a new dance movement. And then we have health aspects and technique. These are the aspects that are considered relevant to learn the correct dance technique in a healthy way. Finally, we have the 2 last topics that are feedback and vision. Feedback covers everything related to how the information is transmitted and perceived. And vision is how our participants envision a tool that can help them to support this process. Coming from these thematic groups and the theoretical background, we derive 4 central design requirements. First, the system should be lightweight. Second, the system should offer implicit feedback for single dance figures. Third, the system should offer the possibility of integrating with an explicit audiovisual feedback for introducing single figures and then mimicking a real-world class. Fourth, the system should integrate sonification elements. In conclusion, in this work we applied neural theory to guide the design of wearable systems for dance learning. We use semi-structured interviews with teachers and students to ground neural theory in practical requirements that can be applied by designers and researchers in their future models. We invite them to consider the long-term impact of these devices beyond the fast learning stage and considering the slow learning and the consolidation that play a super important role in the acquisition of a new motor skill. If you're interested in the details of these insights and the rest of our discovery, I recommend you to check out our paper or contact me.